Welcome Everyday AI. Today, we're diving deep into how artificial intelligence is set to become one of the most critical tools in the race to Mars. With countries like China and Russia accelerating their space programs, it's no longer a matter of if humanity will reach Mars, but who will get there first. And as it stands, AI might just be the edge that the US needs to lead the way. But how exactly will AI enable the United States to pull ahead? In this video, we'll explore the top ways AI is revolutionizing Mars exploration, from enhancing space mission planning, optimizing spacecraft technology, and making deep space communication more efficient, to enabling autonomous rovers and intelligent habitats on the Martian surface. So, buckle up as we explore how AI will shape the journey to Mars and give the US an unparalleled advantage. Space exploration has always been fueled by competition, most famously in the 1960s when the US and Soviet Union raced to the moon. Today, the rivalry has shifted to Mars, with the United States, China, and Russia actively planning Martian missions. Each nation brings unique strengths: China's advancements in satellite technology, Russia's extensive space history, and the United States' standout investment in artificial intelligence. AI is proving to be a game-changer in the race to Mars. Traditional space missions rely on pre-set routines and remote commands, but AI introduces adaptability, self-learning, and real-time decision-making. Imagine a spacecraft that can automatically avoid obstacles or a Mars rover that autonomously selects its path and research targets. These abilities showcase how integrating AI into space tech pushes the US ahead, adding capabilities that previously weren't possible. The US is leading in this effort by incorporating AI across various space exploration sectors, aiming to streamline missions, improve safety, and boost efficiency. To truly understand how AI gives the US an advantage in reaching Mars, we'll explore the specific roles AI plays in ensuring mission success and outpacing other nations in this new era of space exploration. AI is revolutionizing the way we approach mission planning and simulation, which is especially critical for Mars exploration. Unlike the relatively close and manageable journey to the Moon, reaching Mars involves complex logistics, higher costs, and significantly greater risks. A Mars mission demands exhaustive scenario testing, understanding how spacecraft will function under extreme conditions, and predicting the behavior of systems over vast distances. This is precisely where AI's capabilities come to the forefront. With AI, NASA and private space companies can run millions of what-if simulations that anticipate a wide range of potential challenges. For example, AI models can predict how spacecraft might respond to intense solar storms, collisions with micrometeoroids, and unexpected hardware malfunctions. By analyzing these scenarios, AI helps engineers and scientists design spacecraft that are not only robust but also better equipped to handle unexpected issues. Think of it as a digital test lab powered by AI, constantly running simulations, identifying vulnerabilities, and refining mission blueprints based on accurate data. This approach enables mission planners to create reliable strategies while reducing risks that would be difficult, if not impossible, to anticipate otherwise. But AI isn't only tackling technical obstacles. It also plays a significant role in understanding and preparing for the psychological challenges astronauts will face on such a prolonged mission. Isolation, restricted communication with Earth, and confinement are major factors in a Mars mission, with potential impacts on the astronauts' mental health and performance. Through AI-driven models, researchers can simulate how these psychological pressures might unfold, allowing them to plan living spaces, establish daily routines, and develop communication protocols that help keep the crew physically and mentally resilient. By modeling stress responses and behavioral patterns, AI allows planners to anticipate and mitigate potential mental health challenges, optimizing the mission for human endurance. While countries like China and Russia may have strong space programs, the United States' use of advanced AI modeling provides an unmatched advantage in mission planning and crew preparedness. AI's ability to foresee and address both technical and human challenges give the US a substantial edge in achieving a successful Mars mission. Through intelligent mission planning and realistic simulations, AI not only makes the journey to Mars more feasible but also enhances the safety and efficiency of every phase of the mission, from launch to landing and beyond. Autonomous navigation is essential for Mars exploration due to the vast distance between Earth and Mars. Communication signals take between 4 and 24 minutes to travel each way, making it impossible for rovers or spacecraft on Mars to rely on Earth for real-time decision-making. This is where AI's autonomous capabilities become invaluable. With AI, spacecraft and rovers can operate independently, making crucial decisions based on their surroundings without waiting for commands from Earth, effectively bridging the communication gap. NASA's Perseverance rover already incorporates basic AI elements, enabling it to navigate the Martian surface autonomously to some extent. But as we prepare for future Mars missions, even greater autonomy will be required. The next generation of rovers and landers will need AI-driven systems capable of identifying scientific points of interest, avoiding obstacles, and making complex navigation decisions. Such advancements will significantly speed up exploration on Mars, enabling US missions to gather scientific data more rapidly than competitors relying on traditional remote-controlled methods. AI-enhanced navigation is also crucial for the journey to Mars itself. Spacecraft traveling to Mars must maintain an accurate trajectory, make course corrections, and avoid potential hazards in deep space, all of which demand precise calculations. AI can continuously monitor sensor data, detect any deviations from the planned path, and make necessary adjustments autonomously. This not only boosts safety by ensuring that the spacecraft remains on course, but it also reduces the need for constant human oversight, allowing mission control teams to focus on strategic mission goals rather than routine corrections. AI-based navigation provides a substantial advantage over missions relying more heavily on human input and delayed instructions from Earth. By leveraging AI-powered navigation, the US can ensure that its spacecraft and rovers operate independently and efficiently, maximizing the productivity and safety of each mission. This level of autonomy enables American Mars missions to cover more ground and collect more data faster than missions from other nations. In the race to Mars, autonomous AI gives the US a critical edge, allowing its exploration vehicles to adapt to Mars's challenging environment in real time. This advantage could be decisive in achieving mission objectives ahead of international competitors, setting a new standard for space exploration autonomy. AI is revolutionizing resource management for space missions, an essential aspect for the long journey to Mars. Given the complexity and duration of Mars missions, which require extensive life support systems, food supplies, fuel, and infrastructure, efficient resource management becomes vital. Since resources are inherently limited, especially on a multi-year mission, AI's real-time monitoring and optimization capabilities offer a distinct advantage in keeping these missions sustainable. One of the critical roles AI plays is in monitoring essential life support resources, such as water, oxygen, and power. For example, AI can track water recycling systems, predicting when filters need replacement or maintenance, ensuring a continuous and safe water supply for the crew. Oxygen levels can be monitored in real time, with AI detecting potential issues and making adjustments as needed. This ensures a safe and stable environment for astronauts, while also minimizing waste. Power usage, a crucial factor in maintaining habitat systems, can be optimized by AI as it manages temperature, humidity, and lighting within the habitat to ensure a comfortable atmosphere. AI's resource optimization helps to create a balanced environment, preventing resource drain and extending the functionality of life support systems. Fuel management, another critical area, is also enhanced by AI. To ensure the spacecraft's propulsion systems operate efficiently, AI can monitor fuel consumption, perform real-time calculations, and adjust propulsion as necessary. This not only keeps the spacecraft on course but also ensures that enough fuel is available for both the journey to Mars and the landing itself. Optimizing fuel usage allows mission planners to allocate reserves carefully, potentially reducing the need to carry excess fuel and thus lightening the spacecraft's load. The US is already leading in the integration of AI-driven resource management across its space missions, giving it a unique edge over other nations. AI-powered optimization means that American Mars missions can plan for longer durations with fewer physical supplies, minimizing both weight and cost. This allows more room for scientific equipment and other mission-critical assets. By harnessing AI to meticulously manage life support, fuel, and habitat resources, the US can enhance mission resilience, ensuring that both crew and systems operate efficiently for the duration of their mission. This capability places the US at a distinct advantage in the race to Mars, as it allows for extended missions and a greater capacity for in-depth exploration. Establishing infrastructure on Mars, such as habitats, communication systems, and research facilities, is a monumental task, one that AI-driven robotics is poised to tackle. Autonomous robots are expected to play a crucial role in constructing Martian infrastructure before astronauts even set foot on the planet, reducing risks and creating a foundation for more detailed exploration. This approach enables the US to leap ahead by setting up a functional base, making it easier for humans to safely and efficiently carry out scientific and exploratory activities on arrival. AI-powered robots on Mars could work together to clear landing areas, set up solar arrays for power generation, assemble habitats, and even build pathways or structural bases for future operations. The value of autonomous robots on Mars is particularly high due to the harsh environmental conditions, including dust storms, low temperatures, and rocky terrain, which complicate manual operations. With advanced AI capabilities, these robots can detect and navigate hazards, adapt to terrain, and make real-time adjustments, ensuring that setup operations proceed smoothly. This autonomy is essential because the delay in communication signals from Earth to Mars makes direct human control ineffective for immediate responses. The US has a significant advantage in the field of autonomous robotics, particularly through institutions like NASA's Jet Propulsion Laboratory, JPL, which has a long history of developing sophisticated rovers, robotic arms, and exploration systems for various space missions. This expertise provides a solid foundation for the creation of even more advanced AI-driven robotic systems capable of building and maintaining basic Martian infrastructure. Robots like NASA's Perseverance rover and its predecessors serve as foundational models, paving the way for multifunctional robotic units that could undertake more complex construction tasks autonomously on Mars. By deploying these AI-driven robots to construct essential infrastructure, the US not only enhances the safety and efficiency of subsequent human missions but also maximizes the productivity of Martian exploration. When astronauts arrive, they could find a partially developed base with solar energy systems, communication links, and preliminary research modules in place. This groundwork saves valuable time and resources, allowing the human crew to focus on high-priority scientific and exploratory activities instead of basic setup tasks. In the competitive race to Mars, the integration of advanced robotics gives the US a powerful advantage, enabling it to establish a resilient and prepared outpost on Mars and laying the groundwork for a sustained human presence. Mars exploration generates vast amounts of data, from soil samples and atmospheric readings to geological scans and images. Analyzing this data quickly and accurately is crucial for mission success, and AI, especially machine learning, is an invaluable tool for processing these insights, identifying patterns, and predicting outcomes based on past data. An AI system on Mars could analyze soil samples in real time, searching for signs of water or organic compounds, then prioritizing and sending only the most critical findings back to Earth. This selective data transmission reduces the load on Earth-based analysts, allowing scientists to concentrate on the most promising discoveries and take action swiftly. While other nations may still be processing raw data, the US could be using real-time insights from Mars to uncover new findings and make strategic decisions faster. Machine learning models can also be trained to detect important Martian geological features, climate patterns, and potential hazards. This allows AI to not only assist in navigation but also identify safe landing spots, shelter locations, and resource-rich areas. The capacity to analyze and prioritize data on Mars gives the US a significant operational advantage, allowing American missions to proceed more efficiently and make timely adjustments based on real-time conditions. By leveraging machine learning for data analysis, the US is better positioned to lead the next frontier of space exploration on Mars. Communication is one of the biggest challenges in Mars missions due to the signal delay of up to 24 minutes each way. Effective communication is essential, and AI can enhance these systems by compressing data, filtering noise, and prioritizing crucial messages. For instance, AI-driven systems can pre-process images and videos, sending only the most relevant segments back to Earth, which reduces bandwidth usage and optimizes the limited time available for data transmission. Advanced AI models can also predict the ideal times for communication based on factors like orbital dynamics, helping to maximize the efficiency of each communication window. These improvements significantly reduce the impact of delays, ensuring mission-critical data is transmitted as quickly and effectively as possible, even across vast interplanetary distances. The US has been investing heavily in AI-enhanced communication systems, with NASA leading the development of next-generation AI-powered tools for data compression and transmission. These tools are expected to streamline communication between Mars and Earth, allowing US missions to send and receive data more efficiently than their international competitors. By harnessing AI for enhanced communication, the US gains a significant edge in the race to Mars. This advancement not only improves data flow and mission safety but also allows American scientists to make faster decisions based on real-time information from Mars. With AI-driven communication improvements, the US is positioned to lead the way in establishing a reliable and robust link between Earth and Mars, enabling smoother, more responsive Mars missions in the near future. Beyond the technical challenges of a Mars mission, astronauts will face intense psychological stress from isolation, confinement, and the prolonged distance from Earth. AI has the potential to significantly mitigate these human challenges by preparing astronauts before the mission and supporting them during it. For example, AI-driven virtual reality (VR) systems can create immersive simulations of Mars environments, allowing astronauts to practice scenarios such as conducting experiments, troubleshooting equipment, and handling emergencies. This form of training helps astronauts develop coping strategies, familiarity, and problem-solving skills specific to the Mars environment. Once on the mission, AI systems can monitor astronauts' mental health, detecting signs of stress, anxiety, or depression early. By using machine learning, AI can analyze behavior, communication patterns, and physiological indicators to provide timely support. If signs of distress are detected, AI can suggest personalized coping mechanisms or adjustments to their routines, offering a tailored approach based on individual personality traits and stress responses. This continuous psychological support ensures that astronauts maintain mental resilience during their journey. The US stands out in this regard, with NASA leading efforts to integrate AI into astronaut training and psychological support. While other nations focus primarily on the technical aspects of Mars exploration, the US invests in understanding and addressing human factors, recognizing that the mental well-being of the crew is critical for mission success. By leveraging AI for these psychological needs, the US enhances both mission success rates and the health and readiness of astronauts, setting the stage for sustainable exploration and potential settlement on Mars. This investment places American astronauts in the best possible condition to overcome challenges and maximize the effectiveness of Mars exploration. AI's role extends far beyond just reaching Mars. It's essential for achieving long-term sustainability and potential colonization. As the US plans for a lasting human presence on Mars, AI will be crucial for managing resources, growing food, and recycling waste. For instance, AI can monitor the health of crops, predict food supply needs, and adjust environmental factors within Martian greenhouses to ensure optimal plant growth. This level of management is critical for maintaining a reliable food source in an isolated environment. Additionally, AI-driven recycling systems can minimize waste and ensure that valuable resources are reused efficiently, helping to create a more self-sustaining habitat. Such systems allow for the continuous availability of essentials, reducing dependency on resupply missions from Earth. While other countries may aim for temporary missions, the US is poised to establish a sustainable outpost, leveraging AI to create a resilient habitat. With AI in charge of resource management, food production, and habitat maintenance, the US is taking steps to ensure that a long-term human settlement on Mars is achievable, positioning it ahead of international competitors in the quest to settle the Red Planet. So, will the US land on Mars before China and Russia? With the advanced capabilities that AI brings to every aspect of space exploration, it's certainly looking like a strong possibility. From mission planning and autonomous navigation to resource management and psychological support, AI is helping the US overcome challenges that seemed insurmountable just a few years ago. While other nations are making strides, the US's investment in AI may well be the decisive factor that leads to setting foot on Mars first. If you're excited about the future of Mars exploration and want to learn more about the technologies that are making this possible, don't forget to subscribe and hit the notification bell. The race to Mars is on, and we're here to keep you updated every step of the way. Thanks for watching, and we'll see you in the next video.